Welcome to Brain Vision.
Okay, so in this question, we can apply the energy balance equation. Therefore, we have E dot in is equal to E dot out. If we expand it, we have M dot H1 plus M2 dot H2 is equal to M1 dot plus M2 dot times H3. M1 dot is the mass flow rate for the feed water. M2 dot is the mass flow rate for the superheated vapor. And we know H1 is the enthalpy for state 1, which is when the temperature is equal to 50 degrees Celsius and the pressure is 1,000 kilopascal. Okay. And H2 is the enthalpy for state 2, which is when the temperature becomes 200 degrees Celsius and pressure is 1,000 kilopascal. And then H3 here is the enthalpy for state 3, which is just when the pressure becomes 1,000 kilopascal. Okay. And now if we do some arrangement here, we'll have M1 dot over M2 dot H1 plus H2 is equal to M1 dot over M2 dot plus 1 times H3. So what I did is I divided by M2 by each side. Oop. Let me see. Okay. So now let's say that Y, which is the ratio of the mass flow rate of the feed water over the mass flow rate for the superheated vapor. Okay, which is M1 dot over M2 dot. So we can use Y to substitute for M1 dot over M2 dot. So eventually you have Y is equal to H3 minus H2 over H1 minus H3. So now let's use the table at the back of the book. So first, let's use the saturated water temperature table. Okay, so at that table, which is table A4, at 50 degrees Celsius, we can find the corresponding enthalpy is 209.34 kilojoule per kilogram. Okay, and then we can use the table A5, which is the saturated water pressure table. So at 1,000 kilopascal, we'll have the state 3 enthalpy, which is H3 here, is equal to 762.51 kilojoule per kilogram. And then we can use the superheated water table, which is table A6. So at 200 degrees Celsius, 1,000 kilopascal in the table is showing as 1 megapascal. Okay, so the corresponding enthalpy is given as 28.3 kilojoule per kilogram. So now let's plug in back to the equation to determine the ratio. So the ratio should be equal to 762.51 kilojoule per kilogram minus 28.3 kilojoule per kilogram, and then over 209.34 kilojoule per kilogram minus 762.51 kilojoule per kilogram. And this will give us the ratio of the mass flow rate of the feed water over the mass flow rate of the superheated vapor is about 3.73.